Okay, okay. Now this license is coming because I'm trying to connect more than one software to another software. Like Broken is connected to CAD, ETABS as well is connected to Tekla. Everything is connected to something else for better, what you call, yeah, for better transfer. This is the detailing of the beam. Now I assume that no other software will get you as deep as this detail, okay, where it shows you even the top reinforcement, where it shows you the lapping, where it shows you the different sections, the curtailments if there are any curtailments, the sections. This is E, this is BB, this is CC, this is DD, for example. Everything in details, and then finally, it is going to give you the quantity tip-offs. For example, if we see the column, so if you see, it took a strip of column, taking the kicker even, how much is the reinforcement, how much is the labbing, the ground floor, the other labbing, each and everything is almost even. You can see that this is the end, that's why this is bent. Okay. 500 is the depth of the beam. So you can see that the cross section here is 200 into 400. H is 20. There are 6 bars of 20. They are using H. That's 500. T H8. That is 8 diameter length. Spacing is 225. Same here. And once again, the quantity takeoffs are here. Now there are certain software which are going to make the life of even the quantity surveyor easy. But normally we don't use whatever is available. We don't use easy things. We like the hard. Okay. So for example, if we go here, then we get foundation layout. We can see that this software has given you the foundation, the sizes of the foundation with the depth, each and every foundation. And you can see the software is smart enough to give you the columns inside the building. Okay. It will not give you, like for example, if I kept it outside, if I kept it center to center here, it means that half of the column will go outside. And then this is the reinforcement for each and every foundation, each and everything. And then this is schedule. This is your LX, short span, long span, depth, bottom reinforcement um, in X, bottom reinforcement in Y. Now there is a problem with this one. You cannot have only one reinforcement. I think they have done something wrong. Top reinforcement, because all of the foundation are isolated. We didn't have combined. And this is quantity takeoffs. Okay, how many kgs we are using. And then as well, you can go and get report. From the report you can go for let's say material listing, show report, and then it will show you all the calculation required or all the quantity takeoffs. So it says for you beams, each and everything, area, volume, mass, length, cast in place concrete column, everything, how much is the total what you call total mass in kg, slabs, bases, that's our foundation, Loose bars are small bars normally, and then these are the ones as well. So like here they are using mesh. Normally the software will go for mesh if the size of the foundation is big. Okay? And we are going to say it further. We are going to say it. But anyhow, eventually it tells you how much concrete, total volume of concrete, okay, total reinforcement. So here we have around 109 cubic meter, and then we have the reinforcement around 14 tons. Okay. So this is Tekla structural design. Okay. So each and every, if you have noticed, each and every software has its own unique things. Okay. So you shouldn't restrict yourself like the others only for one. Whether it's STAAD, as I told you, each and every software is good at something. STAAD is good for steel. So whenever you are having, let's say, steel construction, it's better to go for STAAD or Robo. If you are designing, for example, for a tower, so if you have got a tower, you can see that modeling of a tower is very hard. Telecommunication tower is very hard. But if you know that there are softwares available which are having ready-made templates, then you should use that particular software. I don't need to go and spend a lot of time to go and model. So one of them is SAP 2000 from the CSI. Have you came across this one, SAP 2000 previously? SAP is used a lot in US. So if you can see here, new mod. If you can see, different ready things are there. Let me just try to. It's one of the software that I prefer to use. It's really good. File, new model. Now you can see you have staircases, but once again it will give you the bending moment, but once again you need to calculate the reinforcement yourself, so it's better to go and use heads for staircase. Storage, for example, elevated water tanks in the frames. Let us go for example, storage. Okay. It says for you water tower number one, water tower number two. If you want to modify anything, you can modify in the elevation and then the diameter, and then eventually you can click on OK. So this is the water tank. So the model is available. uh, that depends, like for example, if you are having an area in which you are not having a water network, in that area you don't have proper water network or lines, so normally what they used to do, they used to keep water in an elevated place. So you will use the gravity rather than using pumping. Okay, so you will use gravity, so the water will go from one place to another place. Like for example, if we are talking about, like for example, areas where mountains are there, it is very hard for me to lay the pipes, okay, and use a lot of pressure. So rather than, maybe you can use this one. I think if you are going to Bosher, there is one in Bosher, but nowadays you are not seeing it a lot. There are a lot of them, but the last one I have seen in Bosher. But nowadays, since pipes are there and everything is available, we don't use to have a lot of these. Okay. So for example, going for new model, we'll go for example for truss. So for example, transmission tower. So it's ready. The only thing I need to only go and place the loading and then design it. Okay. So once again, each and every software, it has its own advantage. Okay. Finally, we are going to go to our software. No, 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 no. True. Slabs foundation you can use Broco or Excel. Once again, that depends on the consultancy that you are working on. It differs. Normally, as I told you, it's easier for everyone to design the slabs and foundation. Stairs is considered to be a slab eventually. It's easier to be designed in simplified method rather than finite element. Okay, so Excel, Tekla, Brocon, all of these are going to be good, and all of these are approved. We don't have something, let us say, not approved, but we don't have something called approved and non-approved in municipality. As long as you are showing your calculation, then these things are fine. Okay. 8 apps is good whenever you are going to go for seismic and concrete design. Concrete design, general concrete design. It's good, but not for C. Robot can do almost everything for you except for postation. Okay. Okay. Can you open which version do you have over there? 2020 or 2021? 2020. What of it? Is it hot? Shall I increase the AC? It's fine. Huh? A zero? Because whenever I lower the temperature, normally students are crying at school. So that's why I kept it 20. Although that it's hot here for me. It's still very good. Anyhow, let us go for new. Can you go for new file? Have you seen new? صور خلاص. So it's recording. Okay. See, there are different things that you need to understand about robot. Um, there are different templates available. Okay, different templates are available. The first one is building design. So normally, if you convert from Revit, bringing to bringing it to robot, it will always be in building design. Building design normally requires a person to have a bit of knowledge in architecture. Okay. And then we have 3D frame. Normally, this is for analysis. It's good for analysis. And then we have shell design. Okay. Now, if you see shell design, it has frames at the bottom, and then it has like a water tank at the top. Okay. So this will allow you to have volumetric shapes, like tanks and whatever, anything which is not regular in shape, plus regular frames. Now, in building design, normally we are limited to regular framing. We don't have irregular shapes. Right? Okay. So when it comes to shell design, it is not only dealing with framing, but it extends that to irregular shapes. Okay. And then we have 3D truss. We have slab design or blade design if you are designing a slab only. And then we have 2D frame, grillage, that's steel design. We have 2D truss. We have volumetric, that is water tank, and then the swimming pool, not dams, let's say not dams. But these are things which are coming in volume normally. Okay. So you can see, or you can say that shell design is a combination of building design and volumetric. Okay. And then we have load bearing, and then we have clean deformation. Now you can see in plane deformation, can you concentrate on your drawing where you can see actually there is a big element but you are taking a small portion of it? Can you see in the picture available for plane deformation? Now there are structures which are so huge that you cannot model in your computer, like for example a dam. Now dam all over is the same, so there is no point for me to go and model a full dam because no computer is going to process that much. So what we need to do, we need to take a smaller portion, a smaller section where we are applying all the stresses, and then that is going to be the same design for the whole dam. Okay, that's why they are taking only a small portion. Okay, and then you have excess symmetry, symmetrical. Excess symmetric means symmetrical. If you can see here and here is a same. And then you have element design. You can do, although if you are using shell design, everything is going to be there. You can copy, and if it's uh, okay, if it's a twin villa, there are engineers who are designing both of them. There are engineers who will only design one and keep the columns which are in contact to be having almost double the loading, because in this scenario you have designed correctly, because it's the same all over, right? So the only difference is coming to the columns which are in common between these two. So for me, rather than having only one loading, I just multiply it by the other loading from the other side. So double times the loading. The other side I don't need to design it. Or if you want to use the mirror in the program, we can do that. And so model only one and then mirror it. That can be done. It depends on the engineer. And then RC element design, connection design. RC element design where we can design beams, columns, foundation, and we are going to see it today as well. Connection design, one of the strongest graphical software in terms of connection design. Whether it's welded, whether it's bolted, whether it's riveted, all of the options are there. Section definition. One of the advantages of this particular software that it has an extensive library of elements. Means whatever elements that you used to know in terms of steel structure are available. You don't need to input. One of the things that normally I don't like about ETABS, for example, that when it comes to material properties, VS Code is not available anymore. Indian is available. So for me, I need to calculate myself the value of E, the value of certain parameters. Now here everything is ready. Okay. A lot of engineers, what they are doing, a lot of engineers, they will come to the ETABS, they will change only the grade of concrete. Now the software does not only understand the grade of concrete, it understands the E value, which is youngest models. If you are not changing it, it means that you are telling me that the cross section is the same all over. Okay. So when it comes to parameters, you need to be careful what to choose and how to choose. Okay, and then here parameterized structure design. There are ready models. You can see that there is H, there is B, and there is L. Can you see? Means the model is ready. You need to input these values, and you can see, for example, till what extent I can extend the columns without failure. Means I'm playing with parameters. This is what we call it as parametric design. Okay, let us go to shell design. Let us go to shell design. Okay. Okay. Now, what I thought to keep, rather than having each and every day, I thought of keeping day after day. So you will practice whatever we have taken the day before. I don't know, but it depends on you. For me, normally I have it 3 days. But if you want to practice, since you are going to use it for a consultancy, it's better that you practice rather than having everything in a rush. Okay. So I'll give you the video of the day, but do not give it to others. Otherwise, I'll kill you, both of you. Okay. So no, it's not. It's not. It's not about giving the data. I mean, I have everything in my YouTube and everything. But why I'm saying like that, because normally when it comes to, like, if I'm sending my recording in the class, that's a different thing, because I'm being too formal, and I don't care who is listening, because I'm not, for example, joking or laughing or whatever. But here, since it is a training institute, I'm trying sometimes to break the ice and whatever. I'm trying to be sometimes funny or joking or laughing and whatever, and it does not feel good to be heard by the others, because they are not in the same position. Right? Okay. Anyhow, now if you see in your software, if you see in your software, okay, I'll try. So again, I'll try to make my screen a little bit bigger so you can see. Okay, going here. Now you can see we have different things. First is access definition. Have you seen access definition? Where you need to put, you know, the grid lines. So you are putting your grid lines, and according to the grid lines, you will be putting your beams column or whatever. Okay, so that's the grid lines. Now, if you can see here, we have X, Y, and Z. Right? Now, do not do anything. I'll just change one thing, and I'll show you why is it important to choose what is available here, or what or which template to be used. So, for example, if I go for a 2D frame, and if I click here, you will only expect that there are two accesses. Okay. So it makes little bit the modeling easier for you, because you are restricting it for 2D. Okay. There is no meaning of putting the other axis. But for example, if we are going, okay, if we are going, see here, for example, because this is made for analysis, as I told you, right? So you will not have structural elements, okay, like column, beams. You are having only bars. Okay, you are having bars because mainly, as I told you, this is for analysis basically. Okay, because in analysis normally you are looking for bending moment and shear forces, where they are not influenced by, for example, the material property, not like deflection, for example. So if we go for our building design, if we go for our shell design, you can see now we are having the structural elements extra, because now here we are supposed to be designing, not only doing the analysis. Is it clear? So each and every template is having almost everything, but whatever icons are shown for you is to serve that particular purpose. You can find the others in the tools and what you call in the geometry and edit, but they are showing for you the most important icons, or whatever important tools to finish this job. Okay, so that's why it's very important to choose the correct template. Like for example, if we are going for let's say new project, and I went for RC element design, it's a design, so you are not expected to see other than this, where this is only column, new beam, new column, new foundation, new continuous footing. The other icons are not there. Okay, so once again, it's very very critical to choose whatever you want. Okay, like for example, we'll go, for example, we'll start here. Can you go with me for new project, and then go for element design, RC element design. Okay, now the first thing, can we go to tools here? The first time you use the software, you need to do the settings. So go to tools, and then there is job preferences. Okay, now the default codes, the default units are American ones. All the software, they are having American. Okay, so for you, can we go for units and formats, and you can you make sure that it's metric? Can you click on metric? Are we okay? Okay. After that, can we go and click on the plus sign here in the units and formats? Can we go for dimensions? What are the units available for you? We have meter for the structure dimension. These are length and width. We use meter. And then section dimensions, that depends from a place to a place. Normally we use millimeter. I don't know in your case you are using millimeter or centimeter. We used to say 200 into 400 rather than saying 20 into 40, but some are saying 20 into 40. So which system you prefer, you need to keep it. Okay. So for the meantime, let's keep it to be millimeter. In your case, what's you are using in the consulting? Because normally Egyptians are using centimeter. Okay. Section properties, like for example I and E. If you are using millimeter for dimension, of course that's going to be in terms of millimeter. Millimeter to the power of 4, millimeter to the power of 3, Z, S, I. So keep it as millimeter. Steel connection in millimeter. Diameter of bars, normally 14, 16, 12 in millimeter. If your diameter in millimeter, then your area normally going to be in millimeter square. So just change it to millimeter square. Are we okay? Go to forces. What is the unit in force with you? Kilonewton, so that's fine. What about the moment? Kilonewton meter. What about the stresses? Meganewton per meter square. That depends. Some of us are saying it in Newton per millimeter square. Some of us are seeing it in kilonewton per meter square for the safe bearing capacity, for example. Anyhow, if you want to change it, you can keep the force unit to be kilonewton, for example. And you can see that there is tons, there's meganewton, there are different things. So kilonewton, and then this is meter square. Okay. Where I can use it for the safe bearing capacity. That's SBC. Okay. Are we fine? Okay. After we finish, can we click on other? Only one changing here. Only one thing to be changed here. Can we change the displacement to be in millimeter? Displacement deflection to be in millimeter rather than centimeter, because normally deflections are going to be very small. Okay. And you can keep the weight rather than kilogram to be kept in kilonewton. Okay. Weight in kilonewton, weight in kilonewton rather than kilogram. Okay. Mass unit is kilogram, force unit is kilonewton. Okay. And then can we go for materials? Now which material is shown to you? British. Now British because the students have used these computers. And when you install it for the first time, it's not going to be British, it's going to be American only. So for example, if I go over here, you can see that these are the material available, and this is one of the advantages using the robot. Everything is almost available. So for example, if you go to Indian, you will see that you have M10, M15, M20, M25, and it goes on. For steel, you are having these for your steel. Now in terms of VS Code, we don't have these. Instead of M, we are having C, and then we have 275, 460, and then 355. Okay. And then the good thing, if you click on modification, if I go for concrete, for example, you can see all the grades are here. All the grades. Now, if you see, the parameters have been already given for you. Can you see that the parameters have been given already for you? Can you try to change from 7.5 to, for example, 25? Can you see that these parameters are changing as well? Okay, it means I don't need to input any parameter. Everything is available by the software. Okay. Other than that, can you see now? Can you see that this is in kilopascals? Okay, because we kept the stresses, if you remember, in kilonewton per meter square, right? Okay, let us do one thing. Click on OK. Go to other once again. I'll go to forces. Change the stresses to Newton per millimeter square. So Newton per millimeter square, megapascals. Okay, click on OK. Okay, so we change it to Newton per millimeter square. Are we okay? Okay, can we go now for materials? Click on modification, materials modification, and then go to concrete. Can you see now the value is in 7.5? Can you see that the unit is changing directly? Got it? Change it. Go for forces. Change this one. Keep it Newton. Newton and millimeter square. Okay. So if you go now to materials, concrete, you can see that the 7.5. Okay. If you change it, you will see that the grades, the E value has been changed as well. Okay. Now there are different codes which are available. There is something called characteristic strength, and there is something called design strength, if you remember. So we're using characteristic strength. Cubical, you have cubical and you have cylindrical. By default, the BS code is using characteristic and using cube. American is using cylinder. Euro is using cylinder. I'm assuming, I'm not sure. We are using cube. Okay. Okay. And then you can go for database. Can we go for database? Click on the what you call plus sign. A lot of things are there. Can we go for building soil? Or before that, can we go for standard loads? Standard loads. Okay. Can we click on the plus sign? Now, can you see, is there any BS code? Okay, so if BS code is not available, you need to use the closest one. The closest one is the Euro. So go to EC001. That's Euro codes. Okay, because if you are choosing ASCE, okay, that's American Society of Civil Engineers, you can see that the units are in feet and pound. So we're going to go for EC001, and then the units are meter and kilojoules. So we are clicking on add. Now you can see that still the red color is with ASCE. Okay. Now choose EC and then there is a tick sign. Click on it. So your default now is becoming to be EC001. After that, go to building soil. There are two things should be appearing for you. One is with M, another one is without M. Right? The one which is highlighted is which one? Without M or with M? With M? Okay. So without is going to be the English units. With M it says for you metric. So you should be picking the metric one. Okay. The most important thing, you will go for reinforcing bars now. Go to reinforcing bars. Over there, I'm assuming that is ACI. ACI? ACI? Okay, so students have chosen, by default it's ACI, American Concrete Institution. So you can go and click on plus. There are different things. 318 is the code of American. There are different versions. They are having 8, I think. They are having 11, 14, 17, 3 years, each and every 3 years. The latest, I think, 19. Okay. Now, anyhow, we have BS2 versions. Can you see? We have 2000, we have 2005. 2000 is coming, updating the version. Do you remember when I said codes? There are two codes, 1997 and then 2004. 2000 is based on the 1997. Okay. 2005 is based on 2004. So if you are designing for 460, then it's 2000. If you are designing for 500, then it's 2005. Are you okay? We said two codes are there. Both of them, I mean, they will not differ. Anyhow, if you want to use 2000, it's fine. If you want to use 2005, it's fine. Are we okay? Okay. After we finish from here, we'll go for the codes. Can we go for design codes? What is the code available for steel structure? Huh? Okay. So that's a BS code for steel structure. If it's not available, go here and then click on more. By default, it's going to be I believe it's going to be LRFD. LRFD is going to be American code as well. L is standing for load, R is for resistance, F is for factor, D is for design. So load, resistance, factor, design method, which is our ultimate. We call it ultimate. They call it LRFD. Okay. So go for more. You can choose here. Can you see? Different codes are there. Different code. A lot of codes are there. Choose BS5950 and then shift it to the other side. Yeah, this is the version of two. Actually, both of them are the same. Both of them are the same. Okay. So BS5950 or BS5950 2000, both of them are the same. Okay. I shifted. By default, you can see now it has been highlighted. Okay. It means that it's a default one. Okay. Rather than going and clicking on OK, you can go from here and continue the remaining ones. So can we go for steel connection? Is there any BS code for steel connection? Can you see any BS code here? If no BS code, you need to choose the closest one. That is Eurocodes. Okay, Eurocodes. After steel connection, can we go for RC? Can we go for RC? Now, if you see here, we have different codes which are available. Okay, we have ACI and we have BS. Can you see in the right side? Do you have ACI and BS? By default, it's ACI. ACI 11 is a 2011 version. ACI 11 metric, that's for metric units. 14M, that is the newer version. And then we have BS 8110. If it's not available from here, you can choose it and then shift it to the other side. Geotechnical timber, we don't design timber. Wood, yani we don't design it. We go for geotechnical and then choose BS and then shift it to the other side. Geotechnical is whatever you need for designing of a foundation. And then we go for load combination. Load combination is a factor of safeties. So will you multiply by 1.4 and 1.6 or 1.5 and 1.5 or whatever? So your load combination, these factor of safety is according to which code? Once again, according to BS8110. So go for BS8110 and then shift it to the other side. Okay. After we finish, there is snow and wind load and there is seismic. So click on wind load. Now you can choose either of the two. Okay, you can choose either of the two. Either ASCE, that's American Society of Civil Engineers, or we can use Eurocodes. Normally, I prefer for the wind to use Eurocodes. Okay, to use Eurocodes. So we're going to choose EN 1991. Okay, 1991 2005. Can you see? And there are, of course, you can see Austria, Belgium, Denmark, Germany, Greece. There are certain small modifications in each and every Eurocode for its own country. Okay, we are going to use the general one, which is Eurocode 1. Okay, and then shift it to the other side. Are we okay? Can we go now the last one for the seismic? Can we go at the bottom? We have IBC. Okay, we have IBC. You can choose either IBC 2012 or you can use UBC. Do you remember the UBC and IBC I told you about? Okay, so UBC is Universal Building Code. IBC is International Building Code. If you go and see, most of the designs we are doing in Oman normally going to be for UBC 97. Okay, but both of them are the same. UBC has stopped. 1997 is the last one. IBC is still updated. So both of them are okay, either this one or that one. Click on OK when you will finish. Now here click on save current parameters as default. Can you see save current parameters as default? It means that next time I don't need to redo the setting once again. This is the final time. Okay. Do you want to really save? Yes. And then click on OK. Yes. Okay. So now we have changed almost everything. Okay. Now let us see this element design. You are in element design, right? So let us see a beam, for example. Can we click on a beam? Now have you got the same as mine or a little bit different? If it's coming like this, you can pull it, bring it here. Have you got like this now? Bigger because my screen is a little bit zoomed. That's why. Anyhow, now oh, so now what you can see, we have a beam whose width is zero point 0.4 and zero point 0.4. So either a column or primary beam. We have secondary and primary. So beams either supported by columns or supported by another beam. Okay. Now for this case, we don't know whether it's a column or a beam, but anyhow there is a support of 0.4. Okay. Now where I can change and play the things. Now if you click on the beam, if you click on the beam, okay, okay, if you click on the beam, you will see that the dimension has been given here. Can you see in general parameters? How much are these? 350 into 600. Can we change it to 200 into 500? And then can you click on apply and see what will happen to your beam? My license. Okay. Yes. Okay. So we have modified it to be 200 into 500. Okay. And then can we go for span geometry? Can we go for span geometry? I want to keep now what I want to keep this side to be 200, the left support to be 200. Why I'm trying to do this? I'm trying to assume that the column in this direction and that the other column is in the other direction. So here it's 200 into 400 and here it's 400 into 200. Okay, so I'll go and change this one, V1. I'll just change the width, the left support width to 0.2. Now can you see that it has been changed directly when you click on apply? Did it change? Okay. Now can we change the length of the element? Can we change the length of the element? Can we keep it to be, for example, 5 meter? Can we keep it as 5 and then apply? Okay. Now you can see that there is a template ready for me. I'm just playing with the value. Okay. So a ready beam is available. Everything is available in front of me. Only I'm just changing the parameters. Okay. Now what I want to do. Now when you click here, anywhere here, you will see that there are certain things at the bottom. You have a cube. Can you see C35 T? Can you see these? Not all of you are going to get the same ones, but we are going to modify. Can you click? Can you double click wherever there is C35 for the cube? Now it says for you C35, right? Okay. Can we check? Can we keep it C35? Yours is that C35. C20 should change it to 35. Okay. Can we go to longitudinal reinforcement? Okay. Longitudinal is the main reinforcement. Main reinforcement for a beam starts from 12. Okay. So what we need to do? First thing, you have T and R. T is 460. R is 250. Do you remember the 250 and 460 that we have seen? Okay, so we are going to choose T. We don't want 6. We don't want 8. We don't want 10 for the main bars. We start for 12. Are we fine? Going for the transversal. Transversal are the links. The minimum links used in Oman is 8 mm. Okay, so we don't use 6, although the code says 6, but we don't use 6. 8 mm. And then click OK when you finish. Okay. Okay, no problem. Close it. Okay. Now can you run, just can you run this calculator? Okay, run the calculator as well. Okay, did you get any error for you? Did you get any error or it's me only? Nothing has. Okay, so everything was okay. Okay, now here, because this is the first time for me to use 2021 version. Okay, I used to work in 2020, and I'll show you what does this mean. Now if you see here, it says for you that it's a detailing condition, and if you go further you can understand what's the issue. It says for you that the problem with the distribution of the reinforcement due to the bar spacing or the support width is too small for the anchorage. Now, if you understand the concept of uh, linking or connecting the beam with the other element, whether it's a beam or a column, we need to penetrate the bars inside. They need to go inside. Okay. Now, in this scenario, what's happening? In this scenario, the width is small. It means the width is not sufficient for me to connect these two elements together. So normally, what do we have? We don't put straight bars. We go for hook, right? So in your scenario, students have already set for hook. How to do it? I'm going to go for here, reinforcement pattern. Can we go for reinforcement pattern? Okay, and can you see that there is anchorage at the bottom? Anchorage means linking the two elements together. And can you see that there is consider hook in your case? You have a tick, right? By default, it's not ticked. Okay, by default, it's not ticked, but the students have already ticked it for you. Now, for me, I just click on consider hook, click on OK, and then OK. Now, if I recalculate, the issue is not going to appear. Okay? So you need to understand what is the error and how to solve it. That's why I have reset the whole 2020 version so you can see what problems might arise for you. Okay. Now, other than that, can we go for 1, 2, 3? Can you see 1, 2, 3? Have you seen 1, 2, 3? Okay. Now you can see that there is mild, moderate, severe, very severe, most severe, and oppressive. This is one of the few software that it will give you the conditions. Other software are going to tell you to give me the cover value. Okay, here, no. You just put for me the condition, put for me the fire resistance, I'll calculate for you. Okay, so for example, let's say for moderate, and let's go for time of 4 hours. Let's go for a time of 4 hours. Okay, and then click on OK. So what did we do? What did we do? We kept it mild and 4 hours. Now we understood mild, moderate, severe, and very severe. 4 hours, 2 hours, 3 hours. It depends on the importance of the building. Although the code has not specified it clearly, but by common sense, an engineer can do. Like for example, if I'm designing my building, I'm designing my house. I'm a person who's living in that house for a long time. It does not require me a lot of time to go and escape from the building. Okay. So 1 hour or half an hour is sufficient for me. Because when you talk about fire, nobody is going to go and search for his items. He will go outside immediately. But when we are talking, for example, about a commercial building or residential or a building which has a lot of tenants, like this one, now 1 hour is not going to be sufficient because you are having a lot of apartments. Maybe somebody is sleeping, so 1 hour is not going to be sufficient. You will take more hours. Okay, so these hours are representing the evacuation period. So that's 2 hours. Now, if you're talking about a school, it goes a little bit higher. So 3 hours, for example, because not all the students are able to move or know the escapes directly. If we are designing a hospital, for example, it requires further more because once again, not all patients are not all patients are going to be able to go by themselves to the escape routes. So you need to have more hours to evacuate. So this is a basic concept of choosing the file. Now I'm assuming that this is 4 hours. Okay. Now can we click on calculation? I didn't put any loading now. The only loading available, the only loading, if you go to load pattern, can you click on load pattern? The only load available is the self weight, if you see. By default the software will calculate the self weight, you don't need to calculate it. Okay. Okay, so the only load is the self weight. Okay, and if you go a little bit further, you can see that the factor of safety taken for the dead load is 1.4 because it's a dead. Okay, and you can see how much was the span, 5, but now it's changing to 5.3 with you as well, right? Because when we design things, we don't take the clear span, we take the center to the center. So 5 meter plus half of the point 2 plus half of the point 4. So point 1 from here, point 2 from there. So it's always center to center. Okay, so here it gives you the center to the center. Now going for the beam view, can we calculate now? Now can you tell me what has happened? It says for you fire design cross section width does not satisfy code requirements. It says for you the width that you have presented is 200 while the code requires 280. Okay, can we go and change the width? Can you click on here? Can you click on the beam? If it's not activated, activate it by clicking on it. Have you clicked on it? Can you change it to 270? Can you click on 270 and then apply? Have you done? Okay, can you calculate once again? Do you see that it's 270 still fail in design? Did you get it fire design failure? Fire design failure? Fire design failure. Because the code says for you the minimum is 280. Now, from where the code says for you 280, is it something set by the code or something set by the software? Now, if you return back and see the code, if you return back to see the code, this is my code. This is the VS code. Now, this is another advantage which is available in this code. It is fully compatible. I mean, the software is fully compatible with the code, so you don't need to worry about the minimum criteria or the minimum dimension. Now we'll see now. Now it says for you if you are going to calculate for the cover and the minimum dimension. Now this is a cover for water, mild, moderate, severe. Can you see? And then this is a fire. Now, did you fail in water or did you fail in fire? The error that you have got. It was in fire, right? Now, if you see, now which side is critical for me? Which side is critical for me? Is it the width or is it the depth for a beam in case of a fire? To keep it simple, this is my remote. Okay. Now, if fire is available all over, which part is going to be easily cut or easily fired? The smaller one or the bigger one? Smaller by common sense, right? So when you are talking about the critical part here, in case of a beam, it's the width, not the depth. That's why they have only considered the width. And if you see the software, it says for you the width. It didn't say for you the depth. When it comes to slab, once again, this is my slab. This is hard to be fired. The easier part to be fired is the depth. So that's why they have considered for you the depth. Now going here, you can see if you are talking about a beam and 4 hours of fire, then it's 280. So that's why we said it's fully compatible with the code. So you don't need to worry a lot about it like the other software. Now going here to the software once again, returning back. So let us keep it to be 280. Let us keep it to be 280 and we are going to check whether it's correct or not. And then calculate. Can you see now that it's fine? Did you get any error? No, it means that you satisfied the minimum requirement for fire. Now we have learned how to model a beam. We have learned how to play, how to solve two errors. One we said a hook, one we said the what you call the fire. Now we are going to tackle another one by adding loads. Okay. Can you see that there is for you? Can you see that there is an icon which is showing some kind of loads over there? Okay. So click on it. It says for you here dead load number 2 because the first one was the self. Okay. So can we put different loading are there, but we are using a uniformly distributed. Right? Can we put, for example, 5? 5. So 5 kilonewton meter, kilonewton per meter for the beam, and click on add. After we finished, you can see that this is becoming to be DL3. Can we change it to? Can we change the nature? Can we change the nature of the load to live load now? Can we change it to live load? And then can we? You can change this one if you want. That will not differ in anything anyhow. Can we keep the live load to be 3? Are you okay? Click on add and then close. Okay. Can we go now to beam load pattern? Can we go to beam load pattern? Can you check now how many loads do you have? We have 3 loads, right? We have the self weight that's having a factor of safety 1.4. We have the dead load 2, which is having 1.4, and then we have the live, which is having 1.6. And the values are there. Okay. Now, if we see here, okay, if we see here, can you try to calculate now? Did you get anything? It says for you environmental condition, the quantity of longitudinal reinforcement has been increased due to perpendicular cracks. Okay, so the software has already, this is not an error, but the software has already increased certain values to avoid crack. Now, what I want to see, I want to see another error. Okay, I want to see another error. Can we change the load? Can we go for load pattern? Can we go for load pattern? And I want you to change for me the loading from 5 for that load. Can you go and click, instead of changing it once again, I can modify it from here. Okay. Can we keep it to be 15, for example? Can we click on 15 and then enter? You can see that it has been changed directly to 15, right? Okay. Can we go and design now? Go to beam view and design once again. Still, it's fine. What did it say for you? Only environmental, right? Okay. Now I'm trying to get the other error. Okay, I'm trying to get another error. So go once again for the loading. Go once again for the loading. Keep it to be 30. Keep the keep the dead load to be 30. Okay. I'm trying to increase the load to see what will happen to my beam. At a certain point, the beam will fail. Okay, and if it fails, what to do? Okay, so let us go to beam view, run the calculation once again. Now, can you see what happens? Can you see the first one was in black, the others are in red? Okay, the others are in red. Okay, now red means it's an error needs to be solved. Black, it means it has been solved by the software. Are we fine? So what do we need to do to solve this issue? If we are getting mainly, if you can see, cracks are there. Okay, mainly cracks are there. Detailing condition, it says for your reinforcement ratio exceeds the maximum. Exceeds the maximum. So the only solution for this one is to increase the cross section. So what I can do, I can go and increase now from keeping it 500, change it to, for example, 650, and then click on apply. Okay, can we click on calculate? Can you see now the errors, the red errors have gone? So now there are certain issues which you need to understand. One is a hook for the connection. Second, we said for fire. Third is whenever loading is too much and you need to increase the depth. Are we fine? Can we go for beam diag? Is it is it right? Okay. So increase the depth. Yeah. How much is your depth now? 4700. But still, I'm assuming that your grade didn't change. I'm assuming that your grade didn't change. Anyhow, just change it. Okay, change it to 700. Still, now it went. Still 750. Are you sure the load is 30? Okay, so increase no problem. No problem. Is it in black or is it in red? Now it's okay. Now can we go to beam diagrams? Can we go to beam diagrams? And can we go for ULS? There is ULS. We have ULS, SLS, ALS. ULS is ultimate limit state. SLS is service limit state. Okay. And you know what are these, right? ULS and SLS. Ultimate limit state, service limit state. Okay. I used to give once again my students an example. Let us say that we are talking about a chair. Now my weight, let us assume my weight is 100, and I want to design a chair, okay, where I'm going to sit at. Now will I design it for 100? You'll design it for something more, whereas you might be assuming that your weight might be increasing, okay, or somebody else will be sitting. So for example, instead of 100, you will design it for 1.4 factor of safety, for example, so 140 rather than 100. You have designed it for 140. Okay. So it means that you are designing for an ultimate load of 140. So that's the ultimate limit state. We are whenever we are taking into account the design or bending into account. Okay. Now when it comes to deflection, if my weight is 100, will the deflection be calculated for 140 or 100? See, when I design the chair, the maximum limit will never change. True. It's 140, whether my weight is 80 or my weight is 100 or 120 or 140. That's the ultimate maximum load can be taken. Okay. That's my maximum limit. Now, when it comes to deflection, no. If my weight is 80, then the deflection will be according to 80. My deflection, my weight is 100, my deflection is going to be 100 according to 100. The first one is ultimate limit state where we are designing for the maximum. Second one is service limit state where we are talking about the actual loading that are happening. Okay, that's the difference between ultimate and service. Ultimate is multiplied by a factor of safety. Service is not multiplied. You are taking the load as it is. Okay, so we'll go for ULS. There are a lot of things here. Can we go only taking theoretical M and theoretical V? We want to see only the bending moment and the shear force. Theoretical M is referring to moment. Theoretical V is referring to shear. And then can we click on apply? Can we click on apply? Can you see the shape of your bending moment? Okay, and you can what you call cruise the mouse and you can see the values, right? And then shear force as well. Can you see the shear force diagram? Okay. Now can we go for beam reinforcement? Can we go for the beam reinforcement? Can you zoom in or click here? Zoom all. Here and here. Whatever window you are referring to, click on it and then click on zoom. Okay, can you see your reinforcement now? Okay, now this is a 2D. This is a 2D or longitudinal section or view. If I want it as a 3D so I can understand more, in this cube there is a home button. Can you click on it? Can you click on it? Okay. So now can you see that it shows you, for example, according to whatever I have done, we have certain bars at the bottom, we have certain bars at the top. Now, taking into account if you're exceeding 750, then you will have intermediate bars. Okay. According to the code, if your depth is more than 750 or 750, more than 750 to be accurate, you are having intermediate bars. Anyhow, you can see that the top bars are smaller than the bottom bars because the bottom bars are the main bars. The top bars are whatever called here. If you see the naming here, we have main bottom. Can you see the red ones now? And then if we click here, just click in this side. One click only. Okay, so assembly top, you can see hanger bar, and then transverse is going to be your link. Transverse is going to be your link. Okay, now can we return to beam view? Can we return to beam view? Now I want to have multiple beams. I want to have multiple beams. Before now we are trying to only solve for one beam. Later we'll learn how to model a lot of things. Okay. If you know how to play with one element, then you can build a lot of elements. Okay. Now can we go to plan beam geometry here? Can we go to beam geometry? Can you see? Okay. Can you see that there is add span, copy span, delete span? Okay. Now can you click on add span? Can you see that another span came? Can you add another one? So now we have 5 meter, 3.5 and 3.5. Can you see? Can we click on this one? Changing changing it, keeping it as 4 meter. Apply. Can you see now it's very easy for me to do multiple spans? Are we fine? It's not necessary 4 meters, just for the sake of playing with the software. Okay. And can we change? I'm trying to have different spans. Now, another thing that we need to understand, can we click on beam geometry once again? Go to the last one. Go to the last one. Can we go to beam geometry? There is something called cantilever. Can you see the cantilever? Left and right. Now we cannot have cantilever on the left because there are spans, but we can have at the right. Right? Can we click on tick on the right? Can you see that the cantilever came to? So once again, modeling it is going to be easy. The only thing that you need to copy, change the span whatever you want, change the depth according to whatever you want. Now we have finished. We can go for beam load pattern. Okay. Now you can see what has happened. There are two options here. Now, if, for example, if I go and delete, so if I go and delete, I deleted the other one, I deleted the third one, okay, or the cantilever, leave the cantilever. Now, if I add the span, it will be taken without the loads. If you copy the span, it will be copied with the loading. Are we okay? Adding a span is different. Copy a span is different. Copy, it will take it as it is fully. Okay, so once again, I'll just copy once again, and you can copy multiple times. Okay, and I want, for example, a cantilever on the right side, for example, and then you can change whatever parameters. Okay, for the cantilever, you need to put it separately because there is no copy option. Okay. You can go from here. So, for example, I want to be full. Okay, so I can change if you want from span 1 to 4, 1, 2, 3, 4, and then I click on modify. So it came over here. Are we okay? Now, if I want to talk about the second loading, which is the live load, I can click on the next. Can you see? Now it will open for me the live load, and then once again it's going to be 1, 2, 4, and then modify. Now you can see it's for all the spans. Are we okay? So if you are taking copy, it will be copied with the loading. If you are adding a span without the loading, but you can add the loading here. So different options, different approaches are there. Are we okay? When you finish, can we go for beam diagrams? And can you see your bending moment diagrams going up and down? Can we see the bending moment going up and down? Are we okay? And then we have, can we go to beam reinforcement after you see the top and down? Can we go to beam reinforcement? And you can see now the reinforcement has been given for the whole beam from the beginning till then. And you can see there are bars at the support because of the negative bending moment. Can you see? Okay. Now you can click here. Due to the negative bending moment we have, due to negative bending moment, if you relate it to here, we have negative bending moment, we have negative bending moment. So of course, top bars are going to be there. Main top as well. There is extra portion here. Can you see? Extra single bar for me, for example. Main bottom. We have main bottom here for each and every span, since they might be different. Okay, and then eventually you can go and get check the beam node. Can you click on the beam node? Where for beam node you can get all the things required. Okay, how much is your span, what is your bending moment, what is geometry, how much is your cover. Okay, how much is your cover? Once again, you can return to the BS code and confirm your cover. Okay, and then how much is your reinforcement, shear force bending moment diagram, uh, how how much is your reinforcement at the end. You can see span from 0.2 to 5.2. You have bottom and you have assembling, which is hanger bar. Okay, and then you have transversal, which is the links. Span number 2, you have bottom, you have transversal as well, and it goes on. Okay, it goes on. And then eventually at the end you have material survey. Have you seen the material survey where it says for you the concrete volume is 3.17, the formwork used is 27.46, total steel according to the diameter, so you're having 8 mm. So this is like quantity takeoffs. Are you okay? Do you want me to give you an example? You try it yourself, or shall we go to the other part? Okay. Everything. Okay, no problem. Let us go for file, go for new, go for new, and then choose shell design. Okay. Then we're going to try to have a simple drawing. Okay, if you understood how to draw the simple drawing, it would you will be able to draw something big. Okay, but I don't want to rush things up, because if I start with a complicated thing, you will stuck at the middle. So it's better to start part by part. Normally, I used to give the students. We used to solve a lot of analysis parts, as you can see. We are going to try to do this one. It's a very simple one, very basic one. Um, and then it says for you that you have. Let me just delete this one. Okay, it says you have to assume a height of 1.5 meter till the ground floor, so from the foundation till the ground, and then you have 3.5, which is a single story height. with 1.5 and 2.5. I'm assuming that you know how to find the loading. In your consultancy, do you have the loading ready, or you are the one doing calculating the loading? Huh? Okay. So he will give you the loading ready. Okay. Now, anyhow, we have different codes to calculate the loading. Okay. And it differs from a building to a building. So, for example, if I'm designing this type of a building, I need to take into account that there is a mechanical unit for the AC. Okay, we don't have what you call compressors, small compressors. There will be a big, huge mechanical, we call it mechanical. So you should know. If I'm designing a home, I'll be having small compressors. If I'm having a window, then the weight of the window AC will be taken by the blocks. So that will not be an issue. Which one? Which one? Yeah, if you want me to teach it, I'll teach you. No problem. Then we'll have here. I have tried to do some of them. Like for example, assume suitable load. I mean suitable wall load. Now dead and live, that depends on the finishing. So finishing normally I prefer to stick to whatever drawing has been given to you. Whatever finishing the engineer has specified. That one you can use code once again. Each and every finishing is having its own value, and then you can add it up. But normally for consultancies they have fixed value for finishes. Okay, so some of them are using 1.5, some of them are using 1. That depends on what is finishing material. So for example, if I'm using granite, then it's going to be different than using regular tiles. Okay, so that differs. But anyhow, I'll show you how or what's the code where you can get these values. Okay. Another thing to be taken into account is sunken. We're having a lot of sunken slabs here in our. Okay. A lot of people they are not familiar with calculation of sunken loads. Okay, so that's another load to be taken into account. Depending on which material you are going to fill, some of them are using sand, some of them are using lightweight concrete, some of them are using loose material. So you need to know the difference between the level of the sunk and the finishing level of the other slabs that needs to be filled with the material. So, for example, if it's soil, then 18 is normally the unit weight. So multiplied by the height of the fill. Okay, that differs on the height of the sunken slab. Water tanks is another headache. Uh, for example, in Saudi Arabia, they're having their water tanks at the bottom, and they are using pumps to avoid huge loads on the slabs. Here in Oman, we are having the water tanks at the top. Okay, so in the what you call in the rooftop, we are placing our water tanks. Okay. How to calculate them? Once again, this is depending on the capacity of the tank. So, for example, if you are having 200 gallons, so 1 gallon is 4 liter. 4 liter means 4 kg. So if you are talking about 200 gallons, it means 800 liters, 800 kg. 800 kg is 8 kilonewton per meter square. Okay, that depends on the area of the tank. Okay, but once again, some of the engineers what they will do, they will divide the whole water tank on the area available. Okay, there is some kind of uh, different approaches between the engineers. For me, I'm considering that to be wrong. Okay. If I have a slab which is like, let's say, uh, the rooftop, let's say that it was 3 into 5, for example, and my water tank is only like, let's say, 1 meter into 1 meter, or normally we are using the circular ones, whatever we call it, not a dome one. Let me take it from here. Ambiente. Take it to Oman. I'm not sure of the spelling, but anyhow, this is one of the strongest, or this is one of the suppliers, big suppliers. Okay, so water tanks. This is how we are teaching the students. So if you go and see Amy and Tatum, man, they're having their catalog, and based on the catalog, you will know the sizes of the water tank. Okay, so different things are there. Man, we normally use the 4G. Okay. So for me, for example, if I'm using 200 gallons, okay, if I'm using 200 gallons, it's going to be 1050 into 1125. Okay, if we take that into account, calculating the area, okay, so we have by 3.14, okay, multiplied by the diameter, which is 1.05, 1.05, multiplied by 1.05 once again as diameter. So by d square divided by 4 will give me the area, multiplied by the height, that is 1.125. So we are talking almost about 1 meter square. The area is 1 meter square. So if I have 200 gallons, that's 800 kilogram. That is 8 kilonewton. Okay, if we divide kilogram to kilonewton, it's divided by 100. So we are talking about 8 kilonewton per meter square. So within 1 meter square, that is the area of one tank, I'm expecting 800 kg in case of the maximum limit of water. Now others, what they are doing, others they will divide that one to avoid uh, more steam. Okay? They will divide among the area. They have the concept saying that eventually the load of the water tank will go to the beams, and that's correct. But you are ignoring another thing, that this slab is going to deflect a lot because of having a huge load in a certain area. Now you are assuming that it's distributed along a bigger area. Okay, so rather than having now, for example, 8 kilonewton per meter square, your load tends to be 3 kilonewton per meter square because you are distributing it for a larger area. Okay, and that's why some of the cases the rooftop will fail. So that depends anyhow based on your engineering consultancy and how they are doing the things. Like for example, if we are talking about a flat slab system, we don't have beams. Normally we keep the loading of the walls on the beams. Okay, but in case of flat slab, we don't have it. So engineers are fighting on how to calculate, because I don't know where the client is going to tell me. Eventually he can go and just put a wall wherever he wants. Okay. We don't have that mentality of client, that if he's having this room to be a bedroom, at any time here in Oman he can change it to a store. Okay. So what happens, he might be constructing a wall anyway. Okay. For example, this was an open area. When I took it, it was an open area. Nobody was expecting that I'm going to put wall here. Okay. But the designer, he needs to take that into account. Okay. So normally what they say, they will try to calculate the maximum possible, okay, the maximum possible weight of loads or weight of walls, and they will divide it among the area, okay, because you cannot have walls all over. So it depends from one consultant or one engineering consultancy to another one. But anyhow, the fundamentals are the fundamentals. You try to avoid uh, critical or a lot of let's say a lot of cases which are going to cause you a lot of problems. Okay, it's better. It's better. It's better to be avoided, because eventually, if you go to the municipality is telling you whatever the consultant is doing is going to be the consultant responsibility, and I'm approving for you, not approving for you that your design is correct. I'm approving for you, saying that your structural drawing is matching your architectural drawing. Anything happens wrongly, it's going to be the structural engineer problem. If anything fails, you will go to the jail for 10 years. So that's why you will see a lot of over designs. It does not mean that some of the designers they don't know how to design, but we are dealing with unexpected changes, or and even like for example, if you are designing for a single story, municipality will always tell you that you need to design for one more story, because you will not know when the client comes and says that they want to have another building. So if you didn't design the foundation to take another story from the beginning, he will cause you a lot of issues. And what happens here? The client will only start construction after 15 years. Now after 15 years nobody knows, or 10 years nobody knows what was the design, where were the drawings, nobody knows. So at that time he is assuming that everything is fine, and he will start constructing, and then the problem will occur. So why the problems are not occurring? Because normally they are doing over design, because you are dealing with things which are not stable. But once again, a lot of issues are there. Like for example, we had one scenario in Com. Do you know Com? The Oasis. واحد ما أعرفه. At that time, I was in Atkins. I was training in Atkins. After returning back from the master's degree, so we went over there. They said there is a problem, and that Com they asked us to come and evaluate. Okay. And normally before they ask you to evaluate, you ask them to send pictures. So to know how severe is the building. Because if it's severe and the condition is really bad, I'll not go and enter, because I'm risking my life as well. They have sent some pictures, but the pictures, it seems that they were not that clear, that there is a huge issue. We went inside. The column, one of the columns has been already what you call crushed fully. The bars are bulging outside. They are broken fully. Okay, so what they have done as a solution for the consultant, he brought a steel column. He brought a steel column just to support that area. But now, one thing that you need to understand, once again, in structural engineering, it does not go in this way. Now, if you are four persons and you are holding a very heavy item, and one person has left the place, the load is going to convert to the three. And if he returns back, he is not going to carry the same loading as he used to do. It means that a lot of loading has already been transferred to the other three. Right? So the same scenario goes for a structure. That column fails, it means that other columns are now being stressed. Even if you put a steel column, it does not mean this steel column is taking the load, because already the load bath has started to move. So what we have done, we have taken a simple sample test. Okay. The column was designed for 40. It was 40 MBA, megapascal. Eventually, we found it to be 15. And at the time of testing, from 40, it was 15. It means that this building is going to fall at any time. Okay. So we reported that this building needs to be evacuated directly. It will fall at any time. Com rejected. Okay. They are the client. They don't want to leave the place. They don't want to have a big mess. So we have sent to what you call Public Authority for Civil Defense. And at that time, it came in the newspaper that Com was closed because of issues. Because they refused, we had to ask the Public Authority for Civil Defense. So sometimes, and it's not only about loading, but it's a lot of things coming after when you think of it. Like when a person came to me, he said, "I want to open a consultancy." It does not. I'm, I'm going to get benefit. He's going to use my license for the consultancy because I'm busy. But you cannot trust this. You cannot easily trust a person who is going to open, because eventually you are the one responsible for anything happens. They will not know who is using that license. They will know the person who has got the license from the beginning. So that's why you will see a lot of over design, but some people are not understanding. They keep on saying that it's over design and over design and over design, but sometimes you need to do it, otherwise you'll not be in a safer side. Okay, anyhow. So now they have given you the live load and dead load, and we are going to assume a suitable load, a suitable wall load. Okay. Now live load and dead load are normally easy to be calculated. The wall load is normally something which is varying because we have parapet. Parapet, the height of the parapet is different. The height from sometimes the ground floor height is different. The other floors are different. So you need to know how to calculate it. And normally we are having normally we are assuming that the load of the wall is going to be around 3.15 kilonewton per meter height. So each 1 meter we are assuming 3.15. Now from where that 3.15 came, now if you are saying um, how many how many blocks are there in 1 meter square, normally we have around 12.5, right? How did we come up with this 12.5? We normally have 1 meter, 1 meter into 1 meter square for 1 meter square pool, and then the block size is zero point 0.4 divided by zero point 0.2. So always for our blocks we have 12.5 blocks per meter square. Okay, approximately the weight of each block is 23. We cannot use the density. A lot of people are using the density. I'm against using the density. Now you are talking about the hollow blocks. Your hollow blocks are not the same all over. You cannot assume the whole, I mean, the same density all over. Okay, so you are talking around, if it's 23 kg, the mass of one block is around 23 kg. Okay, from where you will get it? You will get it from the factories. Okay, so the typical mass is 23. So what I have done, I have multiplied 23. I have multiplied 23 by 12.5 blocks. So I'm expecting in 1 meter square 287.5. Are we okay? Now, do we have something else on the wall? We have blaster. Right? We have blaster. So if we are having a block, normally the block does not need the blaster from, because if you see, there is one side, second side, third side, fourth side, fifth side, and then there are six. Now, when it comes to this block, okay, I don't need plaster from the top. Okay, I don't need a plaster from the bottom because there are still blocks. I don't need from this side. I don't need from this side. Only I need from the outer side. Sure. So there are two sides to be plastered. That plaster is going to be additional load on a beam. Okay. So the plaster unit weight is 21. The plaster unit weight is 21 kilonewton per meter cube. Okay. Normally, normally the plaster layer is around 6 mm, but that differs. But normally in Oman we use 6 mm. Okay, 6 mm in one side, 6 mm in the other side. So we are talking about 0.21 multiplied by 0.006, right? How many sides are there? Two sides. So I just multiply it by two. Okay, so how much is 0.25? 2. The unit is kilonewton per meter square. Because 21 is in kilonewton per meter cube. I multiply it by 0.06. 2 is only the number of clusters. Okay, so it's kilonewton per meter square. What about the first one? What about the 287? What was the unit? It was in kilogram per meter square, right? The weight of, or the mass of one block is 23 kg. For 1 meter square, we have 12.5 kg, 12.5 blocks. So it's kg per meter square. Okay. Now one is in kg per meter square, another one is kilonewton per meter square. We cannot add these two values together. We need to have a common unit. Okay, so 287.5. This is in kg per meter square, right? We say to convert from kg to kilonewton, we need to divide by 100. Okay, is it clear, or do you need me to explain how 100 came? Okay, so 2.875 What is the other value we calculated? Plus 0.25. So we are talking around 3.127. So normally we round it up to 3.15. Okay. So if I have 1 meter height 1 meter height block or 1 meter height wall, then the loading is going to be 3.15 kilonewton per meter. Are we okay? If we are having 2 meters, then multiply 3.15 into 2. 3 meters, it goes. Okay. So now going to the software. Going to the software. Okay. Now we have grid lines, but we need first to understand how to read the drawings. Okay. I think the drawing has been drawn already. Let me. So this is drawn. Let me make it bigger a little bit. Now, what I tried to do over here, I tried to draw by drawing lines representing here. So we have, you see in the horizontal, we have line number, we have line number. Whenever there is a wall, you keep the line. So line number, line number, there is line number, and there is line number. Now in the vertical, we have one, we have two, we have three, we have four. So if you see over here, I try to draw one, two, three, four, A, B, C, D. In well, you have the distance. So this is 0, this is 200, this is 200, how much is the distance? So let us open the robot. Okay, I'll go to the grid lines here. I'll go to the grid lines. It will ask me X, Y, and Z. Okay, it will ask me X, Y, and Z. Now let us start taking X, which is the horizontal. How many points are there? One, two, three, four. Can you give me the first one? Now before entering, what I want you to do, there are two methods of putting the values. Either you put the total value. So for example, I can say 2, and then after 2 we have 3.25, and then after 3.525 we have 4.75, or I can enter the distances. Okay, there are two methods. So method number one, I can put 0. After 0 we have 2. After 2 I need to add 2 plus 1.25, 3.25. After 3.25 we have 1.5, so that's going to go 4.75. Okay, so what did I do? I calculated manually the coordinates in cumulative. Now, normally I don't recommend to go for cumulative, because cumulative is good whenever you are talking about small elements or regular numbers without decimals. And that's not the case now. So what we do, we keep the position to be 0, we keep number of repetition to be 1. Okay, we keep number of repetition to be 1. Are we fine? And I'll play with the distance. Are we fine? So the first distance is how much? The first distance is 2, right? So just click on 2. You will see 0 and 2 came from. Okay. I don't need to touch position. I don't need to touch repetition. I'll change the distance. So I'll click on tab. You don't need even to use a mouse. Tab in your keyboard. Okay. So the other distance is 1.25. And then tab. We have 1.5. Now can you see that the software is calculating? Okay. Now after we finish from X, can we go for Y? Okay, not same thing. Number of repetition is 1. The first distance is how much? The first distance from the button, 2.5. After that, tab, we have 1.5. Tab, 1.5. Okay. We want to change the grids. On the other side, we have it ABCD, right? Do we have it ABCD in the other direction? I don't want 1, 2, 3, and then 1, 2, 3. So what we can do, there is numbering over there. Can you see numbering? Can you change it to ABC? Can you see now that it has been changed to ABCD? Now we finished X and Y. Second step is to go for Z, which is the height. Can we go for Z? So X and Y are the plan, Z is the height. In certain software they are using X, Y is the height. So you need to be careful. Okay. Masar, click on add. You didn't add. Z. The first one is minus 1.5 because it's beneath, and then we have 0. Now I don't need to go and do the repetition because it's direct. The height side are direct. So 0.1 minus 1.5, 0, and then 3.5. Do you agree? And then can we change the numbering to be value? So the heights will be mentioned. Can we have them values? Okay. So it will show me the heights. Can you click on apply? Have you applied? Have you applied? Okay. Now which view is open for you? X and Z, right? X and Z. Now we start. This is a plan, or this is an elevation. This is a plan. We said X and Y are plans. Z is a height. Right? So I need to change in order to draw this one for me. I need to change it to X and Y. Can you click over there and check X and Y? Did you change it to X and Y? I think it's stuck because of the. Still stuck. Okay. Did you give me the distances? 2 after 2. Why is it stuck with me? Okay. Okay. Can you do one thing so we'll be in the comment point? Since I'm trying to play a lot with the changing the zooming and whatever. Can you click on there is a button over there. Looks like a small building. Can you click on structure definition? And then can you click on the first one as well? Can you see that it allows you to shift from one to another? Can you click on the first one, which is building design? Can we go for building design? First one, building design. Okay. Now, if you go to building design, you will notice that you have plan and view. Save it, no problem. You can create a folder for yourself. So we have plan and then we have view. We have plan and then we have view. View is the three, plan is the one. So if you see in gym design, we didn't used to have view. If you are having a bit more than that, it's actually this. So this is X1. Both of them are. But for me, because of the zooming issue, I had to transfer it. But you can continue to do it. Both of them are fine. in here because it was stuck information and we're fixing that. When I shift to the table design, it must come because there's a gap. So what I want to do, now we are going to start moving this. So, see, this is good. So we have these items, slabs, this, you see, these. What? Reducing. I told you. 20 will be what you call. Will be frozen. Okay. Okay. Now, can we see that we click on beams? Can you see that we have steel beam? Can you see that we are having steel beam? Go to RC beam. Okay. If you see your drawing, if you see your drawing from here, you will see that we have different sections, 215 to 400. Can you see? 215 to 400, 215 to 400, 215 to 400, 215 to 515, 500, and it goes on. Okay, let us start drawing by using one section and then we'll change the sections later. Okay, so now I need to use the 215 to 400 because it's the one used a lot. Okay, so we'll go for the robot. Okay, I'll just first I'll click on the three dots here. Can you see the three dots? Okay. Now the grade of concrete, if you see our problem, if we see our problem, it didn't say, so let us use C35. Normally the minimum is 25, but we don't use 25, we use 30 and 35. Okay, so let us use 35, but once again that depends on the consultancy itself. Okay, so we say 215 to 400, right? Okay. Okay, so we have 215 to 400, so 250 to 400, and then I click on add. Are we okay? Okay, and then click close. Now do you see that horizontal beams are there? Tick on horizontal, because we have beams, for example, in stair we have incline, but now we don't want incline, it's only horizontal. Okay, now can we go for drag? Okay, drag, it means instead of, normally we can draw the beam by clicking the first point and then second point and then second point to third point. So for the drag, you need to click the first point, then the second point, then the third point. You don't need to press twice for that, and we are going to see. Now leave it without drag. Now according to my drawing, where are the, let's say the, what you call, where is my A? Okay. Okay, now we can see that we have four lines, A, B, C, and D, right? So if I go and see, the first one, you can see that it's going from A to C. So I need to go from A to C. So I'm going to do from A, I'll just click on the first point and then going to the last point. Can you see a beam came for you? Can you see that the beam came through? Okay, now we have finished. If you go and use drag, you will see that it's connected already. Can you see? It means you don't need to click this point once again. Now this needs to be connected to 2, right? 2 and 2 and C. Okay, 2 and C. So 2 and C. Okay, and then after that we have here. Do you agree? Do not see it. It's not to the scale. Okay. But do you agree that this is going to go to the bottom now? Here, here, here. Can you see that this is going to the bottom? Okay. Okay. Now I don't want this to continue. Because I need to draw the beam from here now, right? So I'll just click here. I'll click in the first point. So now it's going to be from here to here. from here to here, and we continue to have 1, 2, 3, 4. So after that we are going to have here, right? Do you agree? And then here, and then we need to have here somewhere, and then from here to here. Do you agree? Do you agree that these are the drawings now? Okay, these are the beams. Can we go for the view? Can we go for the view? Okay. Everyone, at the bottom there are some icons on the left bottom there are some icons, small icons. Can you see? Can you see them icons? Okay, there is one which looks like an L section. It's called section shape. Can you click on? Now can you see the shape of your elements? Okay. Okay, now what I want to do, I want to start doing the columns, and then we are going to see the other floors. Okay, so once again we'll return to plan. Okay, we are returning to the plan now. Once again, you need to be careful. You have three levels: minus 1.5, 0, and then 3.5. So you shouldn't draw in minus 1.5 the beams, although that you can move them later. Okay. Now, where are the position of the columns? If we return back, okay, we have 4 positions of columns. Can you see over there? Or 6 positions of columns? Can you see over there? They have been specified. Now, what is the section of the column? We have, see now, you can notice that the width in one is 2.5. So this is for short, this is for short. So times out to 15. Now, our console has lots of data to have and section and see how to that is up to 15. Therefore, this we should know how to do this. So we need to define a section for a column which is 215 to 215. Now, returning back to robot. Do you remember that we used the beams previously? Now we'll go for columns. Same thing. Is it steel column or concrete column? Concrete column. We'll click on the 3 dots. Okay. We'll define a new section. The section is 215 to 250, and then click on OK. Two 15 to 250, right? Are we fine? Now, what we want to do, we want to draw the columns. Now first, are the columns going to go downwards or upwards? Now see, you have minus 1.5, then you have 0, and you have 3.5. Now you are in which level? You are in the level of 3.5, right? 3 meter? Did I put it to 3 meter? Your elevation is how much? Why is 3? No, the height here. Okay. Why? Okay, it is at 3.5 meter. Okay, no problem. Can you shift it to the view? Can you shift it to view? Okay. Go to your columns once again. Your columns should be going up, should be going down by how much value? Okay, okay. Now yours is 3 or 3.5? Okay. Now here the Z level is how much? 3, right? Okay. We'll do one thing. Okay, we'll do one thing. Can you click on structure stories? Okay. Now it says for you building base level. Can you see? Can you click here and then choose the bottom? Okay. Have you chosen the bottom? It should come here as minus 1.5. Did it come? Okay. After finishing, can you click 1 point at 0 and then 1 point at 3.5? Okay. Can you see that they came here? Can you see that they came? Okay. Okay. This is one of the issue when you transfer from shell design to building design. In building design, they have already preset heights. Okay, they are not going to take whatever we have done in shell design. But anyhow, we are going to modify it now. Can we click on up? Huh? We have 0 and 3.5. You just highlight the points. Okay. I applied as well. Okay. Okay. Now what I want you to do, can we choose these beams? Can we choose these beams? Now we need to move them, right? Because they have been drawn at the height of 3. We need to have them at 3.5. Can we go to edit and then edit, 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 and then can we go to move or copy? Now do we need to copy or move? Move. So we'll click on move. From which point? For example, from this point, from any of the points to this point, and you can see that it has been shifted. Okay. Okay, now can we go to our plan? And it will keep stucking with me here. Okay. Now in your plan, can you see in 3.5 is it activated for you? Okay. I think for both of you it's fine. For me, because of zooming and zooming. Okay, anyhow. Now what we need to do, I'm going to assume that this is my plan. Okay. Now what I want to do now, the columns, right? So we'll go for the column. What is the height of the column? The cross section. Can you go with me? Can we use the view? Or you can use the plan if you want. Both of them are fine. Okay. Okay. So view. I'll go for column. You make sure that the cross section is the correct one, which is 250 250. After that, what do we have? Okay. Okay. Let me just put it like this. Okay. Now what I want to do, I'll go for What is the height we need? The height of the column from the top to the ground? 3.5, not 4, right? So I'll just change it to 3.5. Are we okay? And then is it going down or up? It's going down from the position of the beams, going down, not up. Okay. Now can you click on the beginning? Can you click on the beginning? Okay. You'll see that the coordinates are changing whenever you move, right? Okay. Now can we see where are the position of the columns? Do we have a column here? Do we have a column here? Can I click here? Can you see that the column came? Did it come for you? If it didn't come, click on the beginning. Click on the beginning first. Did it come? Okay, the second one. Once again, second one. Third one. Okay. Fourth one. Fifth one. Sixth one. Do you agree that now I have drawn my column? Okay. That's it. Okay. Now what I want to do, I want to copy rather than modeling it once again. Now for you it's easier because the plan is activated. Okay, so what I want to do, can we can you click on there are arrows. Can you see the arrows here? Can you see the last arrow here, here? Can you see this arrow? Can you see this icon? Can you click on it? Now when you click on it, okay, when you click on it, I hate zooming. Okay, we have beams and we have columns. Okay, can we highlight the beams? Can you right click on the beams? Select all the beams. Have you done that? Can we now copy to the lower level? Okay, so we'll go to edit once again. Edit, copy from the first point to the second point. Agree? Any problem till now? Everything is fine. Okay. Remaining are the what you call columns to the bottom. Okay. Okay. Now there are different methodologies. We can redraw the columns once again, or we can use an add-on. There is an add-on where we can use it directly. Now, can you do one thing? Can you open your Google over there if you have Google, and can you write um, change bar length, change bar length for robots? Okay, and click. Can you click on enter? You will see that there is an add-on. Have you seen an add-on? Click on it. Okay. Can you download this one? Download it wherever you want, or put it in the desktop. Okay. After downloading it, okay. After downloading it, I'll just open it. It's in the for me. It's in the desktop, for example. Right click, extract. Okay. Huh? ما صار بي. Okay. Correct. It didn't come. Not yet. can we copy from the first floor? Okay, so once again, what I'm trying to do, I can go and right click on the columns, edit, edit, copy from this point to this point. Now you will see that the columns are copied exactly. Okay, because the first height was 3.5, right? Okay, 3.5. So what I want to do, click on that, what you call that that change bar length. You will see by default the bar has already taken the selected items. Okay. Now what is the bar length? What is the bar length? Now we want it to be 1.5 rather than 3.5, right? Okay, so can you click on 1.5 and then change bar length? Now did it collapse like this? Okay. Can you click on Control Z? Anywhere, Control Z. Did you do Control Z? It returns back. Control Z. No need to select. Control Z. Okay. Now what happens? There are two options here. Either move start node or the end node. Now there are two options. Either I need to click on the B in the column to know what's the starting and the end, or to try and then return to the other option. Okay. So for me, I was using N bar, and it causes collapse. Okay. So it rotated everything up. Now rather than doing that, I'm going to select bar start. Now you will see that the height of the column has been reduced to 1.5. Okay. So either you draw the columns once again for a height of 1.5, or you copy and modify. Both options are fine. Yes. Control Z. Choose right click on the columns. Right click on the columns. Next step is going to be changing the position for color. So now I need to change twice rather than changing it. Anyhow, so next step is going to be now formation. We put it over this one. We put it in colors. Now you see the colors are highlighted. Now you can see highlighted. Therefore, because first things and go to that. Okay, still it's stuck in for me. Okay, anyhow, for me, since it's stuck in, can you click on the home button? Now, of course, it's easier to go for the base, but once again, since it's sucking for me, I'll go for the support. Okay, I'll go for support. Can you go for fixed option? Okay, can you click on these points? Can you see now? Have you done the foundation? No, not coming. Are you in shell design or building design? Okay. Can you click here? There is what you have now. the sections, the section. Yeah, we'll change it. No problem. We'll change it. Okay. Okay. So now we will go first for steps, and then we'll go for the. Okay. Okay. Now once again we'll click here. You are in shell design or building design? Building design. Okay. So I'll just transfer to you. Okay. Can we go to the plan? Okay, I'll do one thing. Let me save it. Just one second. Let me save it, and then I'll open it. Maybe the zooming thing will go. وزراء كل الشيء. Still because of the zoom. Okay, no problem. Can you put the top view, or you can have it as it is. Leave it with the home button. Leave it with the home button. Although once again, if it's not stucking, always it's going to be easier for you to draw it in plan. Okay, we'll see how to do that thing. Anyhow, even if it's 3D, now normally we don't put slabs on the ground. Okay, because slabs in the grounds are taken, the load are taken directly by the soil. Okay, only suspended slabs. Okay, except when you are designing for basement. If you are designing for a basement, soil is not there directly, so you need to do it. So what we need to do, if you notice in this drawing, we have the depth to be 120, the depth of the slab to be 120. So what we are going to do, we'll go for slabs from here. We'll go for slabs. Okay, can you see the slabs? Okay, can we click here in the three dots at the top? Okay, first can we call it method, for example, S120? Can we call it S120 slab 120? And then can we change the depth to be 120? Okay, so S120 and then 120. Let me just zoom it for you. Okay. So slab, three dots, S120, and then the thickness or the depth of the slab 120. Make sure that the grade is 35. The grade is 35. Click on add and then close. Okay. So whatever name you want to name it, but the most important thing that the thickness is 120. Once again from here, three dots. You can name it whatever you want, but the most important thing that the thickness is 120 and the grade is 35. Right? Now when you finish, you can see it here. You can see it here from the options available. Can you see S120? Are we okay? Okay, can we click on three dots for the model? Three dots once again. Three dots. This will open for you. Okay, this will open for you. Can we just write two-way distribution? Means loads will be transferring in two directions, not only one direction. The only case where it transfers in one direction is the stair. Okay, because we have only two side beams. Otherwise, all the slabs are going to have four sides. Okay, so can you see now that we are having two options here? One is analytical, another one is simplified. Do you remember when I told you about this one? Okay, can we keep it two-way? Can we keep it two-way? And then click on add. Okay, if it's already available, means the students have done it previously, click on yes and then close. Okay, so we'll change from here. I'll change from here going to two-way, whatever naming I have given. Now, do we have like three options are there? One is circle, if the slab is circle. Another one is the slab is rectangle. Another one if the slab is not uniform, which is contour. Contour means you need to pick the points. Okay, so if it's irregular. Now, do we have anything irregular? No, everything is regular for today. So can we go for rectangle? And once again, there is a tick for horizontal slab, right? It means everything in the same level. It will help you in maintaining the drone. Okay. Now, if you see for rectangle, you need to choose 3 points only. Okay. So, see, first point, second point, and then third point. So it came for you. Did it come? Once again, first point, second point, and then third point. Okay. Last one, first point, second point, third point. Are we fine? Okay. Now, one thing I would recommend always, sometimes when you have very huge mistakes in modeling, okay, the software is going to show you an error and it will close immediately. Okay, so what I would recommend, can we go for tools? Can we go for tools in order to avoid losing a lot of modeling? Can we go for preferences, tools, and then preferences, tools, and then preferences? Can we go for general parameters? You can see that there is automatic save every certain time. Is it ticked or not? Okay. So if you wanted automatic save within 10 minutes, or you can remind, it asks you to remind you. Sometimes you don't want to save. You are trying, okay, you want the software to ask you whether to save or not. So for example, I can let the software ask me whether I want. Okay. So sometimes you are forgetting to save, and this will remind you, and you can set how many minutes you want. Okay, this is number one. Number two, can we go for view parameter? Not view, desktop settings. Okay. Some of us are not comfortable with the blue background, so you can choose whatever thing you want. So dark, black, it's up to you, whatever you want. Okay. So you can change it accordingly. Okay. Now we want to change our beams, right? We want to change our beams. Do you remember the cross section of the beams? Okay. Can we go now and check how many cross sections we have? We have 215 to 400, we have 215 to 400, 215 to 400, 215 to 400. The span is higher here, the span is higher here, and then the cross section is shown. Now, do you know how to calculate the initial geometry? Okay. Now, according to the BS code, let me just try to draw. Okay. According to the BS code, not you, it's recommended for the beam. According to the beam span, divided by 2. This will be divided by 2. And to get the whole of it, we need to do this cover and half of the bound. According to the source code, he is in the half of the bound. You see, then we can take it from the top to the end. There is a cover, there is half. We go in the cover, over the pieces. Only the cover for a minimum value and then value maximum value. And then to 10. And then half of the wall. Only for the beam itself from 30 to 360 and so if you see the cover is half of the diameter, this means it will be around 50. If we talk about the size of two, half of it is 10, plus cover maximum is 50. So 50 In beams, always the cover is higher and the diameter is higher. It slabs its less. So why would they take it to concentrate? So for example, if you go for a slab, these are smooth slabs, so these are fine. Now this, that's why they are having a slab of, for example, 4 to 7. 4 to 7. The shoulder, it's not a one-way slab. It's a two-way slab. The shoulder is formed. You always design for four. So in this scenario, we are going to have 4,000 divided by 32. That's the so 155 into 60. If I have a span of 4 now if it's 16%, 16%, so that's around 20. It's around 20. That's why normally they say for a service, try to not exceed 6 or 7 meters, right? That's your that represents the most practical that we do normally. So from here, from this equation. So what I will do for your future, just prepare like a table for this plan to this plan. This is going to be modeled right. From this plan to this plan, this is going to be modeled right. So you don't need to go ahead. Whenever you're having a model, now this is split into two. Which one is minus two? So directly I can go ahead. Now it's 2 into how much is it? It's 20. Yeah, if you can, what does that mean? Another thing to be taken into account when this plan is small, you need to check the minimum criteria or the minimum must be available. If you don't have any, so that's another thing to be. Normally the minimum is 110 people. You want to be realistic. Or we currently have something below 50 people. We don't want it to go outside the building because the wall is too big. Sometimes when we are talking about commercial residential, buildings also have buildings sometimes outside. Basically, try to find them. In case that is not sufficient, at that time you will move most of residential property. It's not sufficient. And I'll show you some kind of drawings. So what we are going to continue now. Okay. So we have here 250, 250 into 500, and then we have 250 into 550, right? So I'll return back. So here 250 into 500, and here 250 into 550, right? So I'll go for beams. I'll define the new section. My section now is going to be like whatever we have done earlier. Okay. So my new section is 200 into 500, and then click and add, and then the other one is 550, and then I click and add twice. Okay, like I have added two sections now. Okay, click on close. Yeah, no, one is 500, one is 550, right? Okay, 250 into 500, 250 into 550. Okay, so what I can do now, I can choose this beam and this beam together by pressing Control. Click on the first one, hold Control, and then choose the second one. Have you done it? Oh, no. It requires practice. Once you already practice, you see that it becomes easy already. Okay, خلاص. This one, 250 and 550. So go to the beam. RC beam from the three dots. We already, so for example here it's 200 into 550. Okay, so instead of putting the correct one, I have put 200 and 250, 255 or 550. So I'll go once again, I define the new ones. So they are 250 into 500. This is the first section, added. Click on add, it's already added. Go for the second one, 550, and then add it. So now I have added two. Close. Click anywhere, so this selection will go. Choose the first beam. Okay, the first beam, which is having a length of 4.75. You can see the length from here, 4.75. Can you see? Okay, so this one, and then hold control when you want to highlight more than one. Hold control. Now over here, can you see in this table? Can you see that the section is 215 to 400? Can you change it to the 215 to 500? Now can you see that it has increased? Okay, the same thing will go for the other beam. This one is having 5.5 meter. That's why the depth is high. We'll choose the other one as well. Now we are going to put it how much? 250 into 550, right? Are we okay? Okay. Are we fine? Okay. Now I want to confirm whatever I have done is correct or not before going to the design, which will start tomorrow, before doing the loading and whatever. Okay. Now what I want you to do, can we go to view, or you can get it from view. I want to go to display. Okay, I want to go to display. You can get it from there, or I can right click and then go to display. Both options are there. Okay, now what I want to confirm my sections are correct. Okay, so I'll just go to mark with colors. Can you go mark with colors? Okay, first thing, can we go for the thickness? Can we go for the thickness? Click on it and then apply. Can you see the thickness is only S120? It means that I have only one thickness. That will make sure sometimes you are doing a mistake. It will ensure you that whatever you have done is correct. Now after finishing the thickness, can we go for the stories and then click on apply? Can you see now you have two stories, the last one didn't come. Huh? One color. It means that from here. Okay, leave that one. It will not affect anything actually. But because of the numbering, you remember the heights. That will not affect. The most important thing, can we go for the material? Sometimes because of a lot of elements, you miss. One is C35, another one is C30. So can we click on apply? Can we make sure that everything is C35? Okay. Last check. Can we go for sections? Can you see that now we have how many sections? We have three B's and we have one C. Can you see? You have two B's? Okay. Now, what do you have? Which ones do you have? Okay. Do you have 215 to 400? Okay, so that's the most number of beams. And then do you have 215 to 500? 215 to 550, 550? Okay, so the longer ones you didn't change them. So click on them and change them. And then you will see directly they will be added. The next step after confirming everything, the next step is to put the loading. Okay. After putting the loading, we can get the bending moment and shear forces. Okay. So what I'm going to do, uh, you have the software, right? Tanish? Software. You don't have it. Okay. So she will tell you how to install TeamViewer. Okay. And then I'll remotely install it for you. Okay. What I want you to do, I want you to practice doing the same thing. Okay. So I'll give you this one. I don't want to jump in a very huge plan. At least copying and then making the levels and whatever, you should know how to. Plus the settings. So I'm going to upload for you the video. The setting is very important because, as I told you at the first time, it will come only in American. Okay, so apply the setting, draw the same, and then we are going to apply the loading in the upcoming class. Okay. Now, what I was trying to say for you. Ah, okay, let me show you. Let me show you. Okay, and uh, there is automated modular as well available, which we are going to use it next class. Okay. Now, one thing I want you to, or I'll give it to you as well. Okay, this is which I was telling you. This is a part where we used to what you call practice. Like for example, here, if you have a simply supported beam, this is Sky CIV, the one if you remember. So it keeps on telling you in process how to specifically solve that particular problem. Okay, so this is part of the book that I told you about. Okay, so a certain problem is there and it has been solved in three software. And then same for a column, same for a foundation. Okay, and then the same thing how to do the what you call job preferences here. Yeah. Do you remember when we said like the units and everything? So everything has been explained here. Okay, what to be done, the codes, and then certain problems on how to model the full thing and how to get the design of a full thing. So later on, okay, you will see that I have tried to design a full building. Okay, so here for example, see how to model and analyze a two-story building with beams and columns, slabs of 200 depth, should carry a dead load, a life load. We have specified grades. So from the beginning, what to choose, the grid lines, what are the grid lines that you need to do. Okay, so almost everything. How to draw the columns, how to copy them. Now, of course, rotation of columns are going to be very important. So in the upcoming things, we are going to see how to rotate the columns and what direction we are going to see. Okay, so first I want you to practice this one, and then we'll go in depth. Okay. Um, Let me show you a calculation sheet. Do you have you seen a calculation sheet that normally sent to the municipality? It is. مع إنه غريب. ما سألتيهم تيم. You didn't ask. ما جاش فضول تسألي وش الأشياء اللي يرسلوها على البلدية. I was telling her that you were not curious about the things normally they send. Huh? No, it's see, architectural is not a big issue and it's not related to your work. But it's very important to know the structural. That's why I told you when it comes to the loading and everything, everything has been mentioned over there. Like for example, let me choose something. You can see, or shall I make it a little bit bigger? Plus my desktop is full. Okay, so this is an example of a structural calculation that needs to be sent. Okay, so this has been done in ETABS. So this is the thing that I was talking about. You need to define these things when you send to the municipality. And see, like for example, here BS code for wind load has been used. They didn't use say BS 8110, BS 6399. They didn't do the wind and seismic because wind and seismic is normally done if you are having 3 stories, more than 3 stories. Okay, so FCU is 30, blinding is how much. So a lot of information, deep information, are available here which will help you. Like for example, this is what I was telling you. For example, here uh, he has been. This was designed by one of the engineers over there. So he has designed 25. He has used 25 rather than 20. Both of them are fine. Imposed load on the slab, he has considered to be 2. Now others are going to tell you that we are going to do according to the function of the room. So if it's a toilet, it's different. If it's a kitchen, it's different. We don't do that normally in real buildings. I cannot spare a lot of time, especially what you call specifying the life. So we normally take the highest center. Okay, so it's 2. And then wall density. So for example, here is that he's having it as 15 kilonewton per meter as density. Okay, it should be per meter cube. Okay, so floor finish. So he's telling you that if you are talking about typical floor, regular floor is 1.75. Whenever you are talking about the floor, the roof, it should be a little bit higher where you are having uh, what you call waterproofing, where you are having the what you call uh, the sloping and whatever. Okay, so it's going to be a little bit higher. Now this is what I was talking about. So MEP or the mechanical room is 7.5, and then water tank is going to be 12 kilograms. So once again, for buildings, for homes, normally it's going to be regular, what you call the regular compressors that can be added as a dead load on the slabs all over because you don't know where he will place it. But when it comes to central system, you need to do this one because it's very heavy. Okay. I don't think that it's open. Next time I'll check if this is open so we can I can take you over there to see. Okay, mechanical. It's a huge room. Okay, it's a huge room. So we are talking around maybe not lesser than 2 to 3 tons maybe. Okay. And then water tank, 12 kilonewton per meter square. So in this scenario, they are using 300 gallons. So 300 into 4 is 1200 divided by 100. This is what I was telling you. The analysis is done in ETABS. Column and beam design is done in ETABS, but I told you the slab and foundation is normally done Excel because they are easier. Okay. Maximum steel bearing capacity, you should get it from the municipality. Okay. So certain things you need to mention. Okay. Like for example, the cover. Now, according to the code, it says the minimum cover is 40, but we regularly use 50. Okay. So a lot of things are very important. Okay. A lot of things are very important. Like for example, Do you remember when I told you about the column being outside? See here, see how the column is available. So although that the column shouldn't go outside, but a lot of designers what they will do, they will somehow ignore the moment which is happening by taking considering that is fully actually loaded. So they are taking the worst scenario, increasing a lot of reinforcement. And once again, that is due to the fact uh, that normally when you convert from Revit, normally it goes as center to center. But if you want accurate, if you want to save, then it's going to be regular, whatever is available. Like for example, here, see now, now whatever he means, this beam should be straight. Okay, but due to the fact that it's going from center to center, okay, this is what's happening. That's why I told you to check the designer in your case. And this is already approved yet. Municipality does not care. Okay, municipality does not care whatever you do. Okay, and this is the Excel that I told you about. Okay. Even like we are teaching the students from this level now for the college as well that they need to use the Excel for most of the cases. Okay. So this is the Excel for the slabs, and then there is Excel for the foundation. This is the Excel for the foundation, and we are going to see it next class hopefully. I'm going to try to show you. Now, other than that, see for the column, we try to the maximum as well for the column and the beam to be kept as 200. Okay. Why we don't prefer for especially residential, we don't prefer that the column is going to go outside like this one. See behind you. Now this column I mean, is causing a lot of issue in terms of even placing everything. Now I can understand this one because this is a wall now. Like he cannot put the wood outside. That's why he has placed the wool inside. So certain things you cannot do. Here, either he needs to rotate it in the direction of the wool, or he needs to bring it here. So he is having some kind of restriction when it comes to residential commercial. But normally in residential we don't have a lot of restriction. Although in your design 12 might be okay, but the municipality will never approve for you 12. Okay? It will return even if your design is correct. Okay? Because once again, as whatever we have said, you don't know what is going to happen. Okay. So that's a column. This is your ground floor for a length beam. Okay, and once again, if you see all the beams, okay, see here B1, B2, B3, B4, B5. These are regular beams. BB1 that is length beam. Okay. HB1 is representing hidden beam, and then we have a cantilever beam. Okay. Now you can see in most of the cases for regular beams, not hidden, of course, regular beams, we are having 200. We don't want our beam to go outside of the wall as well. Okay. So try to keep that in your mind, limiting the width to 200. Only if it's required, I'll go further. Okay. The beam according to the span. This is what. Do you remember the calculation that we have given? So according to the length of the beam, according to the length of the beam, you will be having one depth. The width is 200, so you have your cross section now. Now, but the scenario goes if you see he is not having a lot of, or we don't have normally a lot of beams. Okay, so that's why I told you you need to have a range. So, for example, anything from normally what we say for the students, anything from 2 to 4, for example, or 2 to 3 is going to have 400. Anything from 3 to 4 not precisely one beam. Anything in that range is going to have this value. So later on, all of that category is going to be called as B1. The other category we call it as B2. And you can see um, the one difference is the size between the beams, and the other difference is reinforcement. Okay, the other difference is reinforcement. Like here, for example, between B3 and B4, they are exactly the same. So there is no point of having B3 and B4. Okay. Um, that's it. I think for L is how many legs in case of a hidden beam, where the links we are talking about the links. That's it approximately. And the other, the same thing. See, if we have once again, this is an ETABS, right? Okay. The heights and whatever, and you can see we have taken 1.5 as a depth. So some are going to start from minus 1.5, some are going to start from 0 and then raise it to 1.5. Both of them are fine. The base is 1.5 minus 0.1.5 or 0. Both are fine as well. See, that's a problem. That's a problem when it comes to ETABS. As I told you, um, see here, like he has changed the grade of concrete, but he didn't change the other parameters. Like for example, for steel rebar, he's using 420. Why 420? Because that's whatever available according to the American code. Okay. So it means instead of using the full strength of the steel, he has reduced the steel. It means that you require more steel. Okay. So that's why when it comes to ETABS, since a lot of things are not available, you need to be careful. Okay. So for example, instead of 5 bars, he's supplying 6 bars. That's it, I think. This is Brocon. I told you Brocon, right? So see, for example, here we didn't use Excel. We used Brocon for the slab and foundation. Huh? Municipality takes everything, even Excel. They don't say for you, as long as everything is clear, and they shouldn't, because everyone is having different program. I don't see a point of restricting a person to use whatever he wants. So whatever is broken, some of the consultancy are doing everything in Excel, even the beams and columns and everything in Excel. He does not even use analysis software. That approximate for small projects rather than wasting a lot of time. He feels that going for Excel, although that the cost might be 50% extra if you are using an Excel, because Excel is only an approximate method. So rather than using software for your analysis, okay, you are increasing 50% to the client, 50% cost, and this will make the client going from one consultant to another consultant, which is a cost. If it's a small building, it's not that much, but whenever you are talking about huge amount of money, like when you construct, you are talking about thousands. So 5,000 will differ a lot. I mean, if you are paying 80,000 or 85, and that because only the designer has done extra things which are not necessary. Okay. So we'll see further problems, but once again, whether you are using Brocon or you are using Excel, you require to get the analysis from the software, whether it's ETABS or Robot or whatever. These analysis parameters, we need to get them from the analysis software. But we don't prefer doing the foundation and slabs. But there is a way when it comes to Robot. I'll show you how to control them. Okay, finished for the day. if you have any question. I know that we have went very abroad, but I think it will be good for your future. So I'll send you the video. Send you the video.